The choice of working on something related to art and culture comes from the fact that Italy has a unique artistic heritage to which IT applications could give a relevant improvement in terms of visiting experience. Moreover, in a world in which technology and technical progress are becoming more and more important, art and culture must keep up with the times to maintain a certain level of attractiveness to visitors that are getting used to dealing with technological innovations in different aspects of everyday life. In the platform, there are an MQTT broker and a room catalog to which all the other agents are connected, through MQTT protocol with the broker and via REST with the catalog. The catalog, in particular, collects some useful data such as the broker's IP address and port, inter-acquisition time, time after which the data are updated, value thresholds, museum timetable, etc., and stores all the devices which join the platform. They are defined by an ID, the type of device, Arduino or Raspberry, and the sensors mounted on them. In addition to those agents, there are some ThinkSpeak channels used to collect measurements coming from sensors and to send them to the Freeboard dashboard and to the relative Telegram bot, used by the museum staff to control the platform. The Telegram bots are two, as there is another one which is used by the museum's visitors to get some relevant information about the exposed artworks. In the end, there are some control strategies which monitor what happens in the space controlled by the platform and can perform actions, for instance control of cooling system and lights, if necessary. Each room is equipped with a system able to detect if a person goes in or leaves the room itself. This is possible thanks to an Arduino board to which two motion sensors are connected. When a person enters the room, the motion sensor at the entrance detects him or her, and then a proper message is published by an ESP8266 module connected to the Arduino itself under an MQTT topic to which the control system is subscribed. It notifies the arrival of the person and then sends an MQTT message under another topic to which another ESP8266 is subscribed. This module is connected to an Arduino board equipped with the relay modules in charge of controlling cooling system and lights. If lights are off, they are automatically switched on when the person enters the room, as the second ESP8266 module receives the MQTT message under the topic related to lights control. When instead the person leaves the room, the other motion sensor performs the detection and the number of present people is updated by the control system. Moreover, if the room remains empty for a certain time, obtained through a GET request to the room catalog, the control system itself switches off the lights with another MQTT message sent under the related topic to control the relay module. The Freeboard dashboard is used by members of the museum staff to have access to information about the controlled room and to perform some actions such as managing thresholds for the different parameters and switching on or off the cooling system and the lights. Data, which are humidity and temperature measured by a proper sensor connected to a Raspberry Pi board and number of people, are updated regularly according to an inter-acquisition time got from the room catalog via GET request. Their values and trends with respect to time are shown on the dashboard itself. The Raspberry Pi board executes several programs, among which there is one dedicated to retrieve data of temperature and humidity from the related sensor and of people in the room via MQTT. These data are then sent to some ThinkSpeak channels from which they are then retrieved by the Freeboard dashboard and by the Telegram bot via REST web services. In particular, on the dashboard data are updated regularly, as said before, while the bot features a proper button to perform a GET request and obtain the data themselves. The dashboard and the bot allow device interaction too by sending MQTT messages under the topics used to control the relay modules. The first example is about turning on the lights with the dashboard. In the top left corner of the screen there are also two switches which show the status of the two systems cooling the lights. Another example shows how to switch off the cooling system with the dashboard. The last example is about lights control with the Telegram bot. The platform provides some topics related to alert notifications. Messages are sent under those topics when the temperature, humidity and people values are above or below some thresholds. Here is an example with the values of temperature, which in this case are sent manually to simulate the behavior of the system. Moreover, if the temperature goes below the minimum threshold, there is an alert, while if it goes above the maximum one, apart from the alert, the cooling system is switched on through an MQTT message under the related topic. The cooling system is then switched off if the temperature returns below the maximum threshold. When the thresholds are exceeded, alerts are sent to the Telegram bot and to the dashboard, which are subscribed to the related MQTT topics. This guarantees quick updates to all the staff. The last control task is about thresholds, which can be modified using the dedicated panel of the dashboard. It is important to underline that the system accepts correct values only. The bot allows threshold management and display too, featuring a button to choose which threshold should be changed and another one that shows all the current threshold values. The second Telegram bot, as said, allows visitors interaction with the exposed artworks. Each visitor can send a photo of the QR code present next to each artwork to get an instantaneous description of what he or she has in front. A local database is used to store information about the artworks themselves.